So at work, my team is going to be building a new search algorithm. And when it comes to search, really my favorite search experience is the Sublime Text Goto Anywhere command. The Goto Anywhere command essentially allows you to find files on your file system using a very fuzzy matching algorithm. So for example, let's say I have a list of primates here and I want to search for Homo sapiens, but I don't necessarily know how to spell it, so I might search for Hosan. And what you can see is that Hosan was able to bubble Homo sapiens up to the top of this list of primates because it was able to match the sequences of characters HO, then SA, and then N, which is exactly what we have here, HO, SA, and then N. And so we can search for other things like ACA, we can search for G-illa, which will find us gorilla, and you can see that it's matching, again, these partial matches in sequence against the values, and it's doing it fairly quickly. Home say. All right, so let's take a look at how this works under the hood. Well, first of all, I should say that what I wanted to do is break this up into a two-phase algorithm. One that first locates the items that I want to display, and then a second phase which actually goes through and breaks up the search results into these various segments. And if we look at the elements here, what we can see is that each of these matches is inside of a separate span because some spans have to have the on and some spans have no special denotion, so they are not bold. So let's go ahead and take a look at how that works. So let's look at our app component. This is where we're consuming the fuzzy search, which is being provided by this fuzzy matcher. And you can see the template here is super simple. I have my input. When there's a model change, I apply the filter to my list of primates. And here you can see that I have a collection of matches. I'm simply looping over the list of matches. That is the list here. And then within each match, I am looping over a list of segments, and that's the spans that we just saw in the Elements tab. And each one of these segments may optionally have this -- on modifier, which is what makes it bold versus the non-bold portions. Okay, so let's take a look at our apply filter. So apply filter takes our primates, and then again we're going to process this using a two-phased approach. The first phase is we're going to map that collection of primates onto a score. So we're going to use the fuzzy matcher to score the value, passing in the primate name and the current input filter. And this is going to return an integer of some sort. We don't necessarily know what the implementation of this number is, but we know that the higher the number, the better the search result. So then I can take that scored result and sort it, again, using a higher, the greater than here, to bubble it to the top of the collection. So things that match with a higher score are going to bubble to the top. Now once I have the sorted values, I'm going to just slice off the top 20. So we actually have hundreds of primates, right? I can open up my primates collection here. We have just shy of 400 primates, but I'm only going to show you the top 20. So when we look at this list, we've scored 400 primates, but then we're slicing off the top 20 of the matching results, and then we're going to format those, which is our phase 2. So once we have this top 20, we then map that remaining 20 items onto a segmented value thanks to the fuzzy matcher. So again, we're going to pass in the name of the primate and the input in our current filter, and we're going to break that up into segments. And then of course, these are the segments that we are looping over in our NG4, and we're going to be looking for that is match on that segment. So let's now take a look at the fuzzy matcher to see how this all works. So the fuzzy matcher class essentially has two methods which match the two phases of the algorithm here. So parse value, which is phase 2, and score value, which is phase 1. And I'll just go through these really quickly. You can look through them on your own time. Essentially what we do is we're just going to loop over the entire value length, and then for each character in the value, we're going to match it to, or we're going to compare it to the input character at the current sequence. And if it matches, we're going to increment the score. I'm going to give a little bit of extra weighting for two characters that are right next to each other. So sibling characters are higher rated than non-sibling characters. And then if we don't match, I'm simply going to subtract from the score. So this is a very simple algorithm. You can get much more complex. Forrest Smith has a very good solution, which he has all kinds of different weights based on where strings are and whether or not they're near delimiters, which is much more intelligent than this approach. This, again, is simply incrementing a score for matching characters and then decrementing a score for non-matching characters. And that, again, gets us to this first phase of the algorithm, where we loop over the list of primates. We score each one based on the input. Then we're going to sort those based on the score, slice off the top 20, and now we're going to go ahead and parse those. We're going to get that value. So let's take a look at that parse value. So parse value, we don't care about the score in the parse value. The score's already been applied, so now we need to format that subset of records that we want to show. The general approach is fairly similar. We're going to loop over that entire value. Again, we're going to compare the current value character to the input character, and we're going to start adding to segments in which the match is true, or adding to segments in which the match is false. I'm not going to step through this algorithm again. It's just kind of loops and comparisons. You can check it on your own, but essentially, eventually, it will return this collection of segments. That collection of segments is, again, what we're using here in the ng-fork to actually format the individual primate matches, sometimes with the --on modifier for the bolding. So that's kind of the simple implementation of the Sublime Text fuzzy search experience, which, again, I think is just an amazing search experience. I don't know, Sublime Text is like blisteringly fast. I don't know how they make it so fast. I have projects that have tens of thousands of files, and when I search for something in the Goto Anywhere command, it is just instantaneous. And so that's what I'd like to try and build in Angular, and hopefully this was interesting.